Hello friends, in the classes of Collegiate-Physics, in lecture number 8, you all are welcomed. In this lecture, we will describe the collision in a plane in C frame of reference. This is an example of C frame of reference. We will see in this question what are the differences in explaining the collision in C frame of reference from that of L frame of reference. So suppose that there are two particles of mass m1 and m2 and they are along x-axis in L frame of reference. The distance of m1 particle is x1 from the origin and the distance of m2 particle from the origin is x2. So, as we have defined, the distance of center of mass C from the origin will be given by x is equal to m1 x1 plus m2 x2 divided by m1 plus m2. Now let us differentiate this equation with respect to t. Then dx by dt is equal to this much. Here dx by dt is equal to v, where v is the velocity of center of mass in L frame of reference. dx1 by dt is E1, where E1 is the velocity of m1 mass in L frame of reference. Similarly, U2 is the velocity of m2 mass in L frame of reference. So V is equal to m1 E1 plus m2 U2 divided by m1 plus m2. Now, suppose that the second body is at rest in L frame of reference. Then U2 will be 0. In this case, V will be equal to m1 U1 divided by m1 plus m2. Here V is the velocity of center of mass in L frame of reference. E1 is the velocity of first particle in L frame of reference. So we see that the direction of velocity of center of mass is same as the direction of velocity of m1 particle in L frame of reference. Both are along the same direction. Now, we have assumed that E1 is the velocity of a first particle in L frame of reference and the velocity of center of mass frame of reference is V. So, the velocity of first particle m1 in C frame of reference will be equal to E1 dash is equal to E1 minus V, and putting the value of V, we get E1 is equal to M2 E1 dash is equal to M2 E1 divided by M1 plus M2. E1 dash is the velocity of M1 particle in C frame of reference. Similarly, the velocity of second particle M2 in C frame of reference will be denoted by U2 dash, and this U2 dash will be equal to 0 minus V because U2 is equal to 0. So U2 dash will be equal to minus M1 U1 divided by M1 plus M2. So in C frame of reference, the velocity of M1 and the velocity of m2 have been determined. Now suppose that after the collision, the velocity of first particle m1 becomes v1 and the velocity of second particle m2 becomes v2 in L frame of reference. Then after collision, the velocities of m1 and m2 in C frame of reference may be represented by v1 dash and v2 dash, and the value of v1 dash will be equal to v1 minus v, and the value of v2 dash will be equal to v2 minus v. Now, since in C frame of reference the center of mass is always at rest, therefore applying the law of conservation of kinetic energy, we will have the kinetic energy of the system before collision will be equal to the kinetic energy of the system after collision. Therefore, half m1 e1 dash square plus half m2 u2 dash square will be equal to half m1 v1 dash square plus half m2 v2 dash square. Now, the value of u1 from equation 8 will be calculated. E1 dash will be equal to minus m2 u2 dash by m1, and v1 dash will be equal to minus m2 v2 dash by m1. These values of e1 dash and v1 dash will be substituted in equation number 12. That is, e1 dash will be substituted from equation 10, v1 dash will be substituted from equation 11, and then when we will solve this equation, we will get u2 dash is equal to v2 dash. Similarly, in equation 12, this time we will substitute the value of u2 dash and v2 dash from 8 and 9. And then this equation 12 on solving will give this result, e1 dash is equal to v1 dash. Now remember, e1 dash is the velocity of m1 particle before collision. v1 dash is the velocity of m1 particle after collision. Both are equal. This means the magnitude of velocity of a first particle before collision and after collision are equal. Similarly, the magnitude of velocity of second particle before collision and after collision are equal. So we conclude that in perfect elastic collision in C frame of reference, the velocity of first particle will not change after collision. Similarly, the velocity of second particle will not change after collision. The change which can take place is the change in direction of velocity. And this is all about the study of collision in a plane in C frame of reference. The detailed note of this question is given in the last of this video. Thank you for attending the class. Thank you.